So, let me ask you something. What do you think is actually going to be on our plates in the year 2050? It might seem like a long way off, but the answer could be a lot closer and honestly, a whole lot smaller than you might think. Let's dive in.
Take a look at this number, 15,000 liters. I mean, that's a lot, right? Well, that's how much water it can take to produce just 1 single kilogram of beef. It's a pretty mind-blowing figure, and it points to a much bigger problem. Is our current food system even sustainable?
And really, that one statistic just sets the stage perfectly. So for this first part, let's really dig into the immense pressure our planet is under when it comes to the challenge of feeding everyone.
Okay, so this right here puts the whole challenge into perspective. By the year 2050, we're looking at a global population of around 9 billion people. Now, to feed all of them, we're going to need a massive increase in food production. And, well, our current way of doing things with traditional livestock, it's just not going to cut it.
So where do we even begin to look for a solution? You might think it's some futuristic, high-tech, lab-grown invention. But what if the answer isn't new at all? What if it's a six-legged superfood that's been on the human menu for thousands of years?
Yeah, there's a technical term for it, entomophagy. And while that might sound a little strange to some of us, it's a practice that's actually deeply woven into our history and even our biology.
And I want to be clear, this is not some niche, futuristic food trend. Right now, as we speak, that number, 2 billion, that's how many people around the globe regularly eat insects as part of their diet. For countless cultures, it's a totally normal, traditional part of their cuisine.
And when you break it down, it's just how widespread this is. We're talking about a practice that happens in over 113 countries, with more than 2,000 different species of edible insects. But here's what's even more fascinating. We're literally built for this. Fossil records show our primate ancestors ate insects, and modern humans, we still carry the gene, it's called CIA, that produces the enzyme we need to digest chitin. That's the main stuff an insect's exoskeleton is made of.
So, okay, history and tradition are one thing, but what's the actual case for insects today? Could they really be the ultimate superfood? Let's take a deep dive and see what the hard data says.
First things first, let's talk protein. On a dry matter basis, insects are absolute powerhouses. Crickets, for example, can be up to 80% protein. 80%. Now compare that to chicken at around 55% or beef at just 40%. It's not even a close competition.
And it's not just what's inside them, it's how efficiently they make it. This part is a real game changer. To gain 1 kilogram of weight, crickets only need about 1.7 kilograms of feed. Cattle, on the other hand, need a full 10 kilograms for that same kilogram of weight. That is a massive difference in efficiency.
And hey, it goes way beyond protein. Just look at this micronutrient comparison. Crickets pack more than double the zinc of beef, more than double the vitamin B12, and, get this, nearly 10 times the calcium. They're basically tiny walking multi-mineral supplements.
Now what about that exoskeleton we were talking about? For a long time, scientists thought chitin was an anti-nutrient, something that actually blocked our bodies from absorbing minerals. But the latest science has completely flipped that idea on its head. We now know that chitin acts as a prebiotic fiber. That means it's food for the good bacteria in your gut, which can help support a really healthy microbiome.
Okay, I know what you might be thinking. If insects are this nutritious and this sustainable, why aren't we all eating them already? And that's a perfectly fair question. It brings us to the very real hurdles that are still on the plate. So the biggest hurdle is probably this one right here. It's what researchers call the yuck factor. In many Western cultures, we have this deep-seated bias that connects insects with being unclean, with being pests, and definitely not with being food. But this isn't some wall we can't get over. Research shows there's a pretty clear path forward. First, education. Just teaching people about all the benefits makes them way more willing to give it a try. Second, and this is key, is processing. When you turn insects into powders or flours and put them into familiar foods like pasta or protein bars, that disgust factor drops dramatically. And finally, just like with sushi years ago, it's about repeated exposure and creative cooking. It can absolutely become normalized over time.
Now, moving past cultural feelings, there are, of course, legitimate food safety questions. We have to consider everything from allergies and anti-nutrients to potential contaminants, just like we would with any other food source.
So let's focus on what is probably the most significant risk, allergies. And the main culprit here is a protein called tropomyosin. And here's why that specific protein is so important. Tropomyosin is the exact same protein that causes allergies to shellfish like shrimp and crab. This is what's known as cross-reactivity. And the warning here is crystal clear. If you have a shellfish allergy, you should be extremely cautious about eating insects.
So, after weighing all the amazing benefits and the very real hurdles, let's bring it all together and take a final look at what this really means for the future of our food.
This chart really puts the whole environmental argument into stark relief. I mean, just look at it. Per kilogram of protein, crickets use dramatically less feed, land, and water. And when it comes to greenhouse gas emissions, they're practically negligible compared to cattle. It is a true night and day difference.
And here's another efficiency metric we don't always think about. How much of the animal can we actually eat? For crickets, it's about 80%. But for cattle, it's only about 40%. The rest is waste. With insects, you just get more food from less animal. It's that simple.
And the technology here is only getting better and better. Scientists are developing things like textured insect protein to create meat-like products. They're biofortifying insects with extra nutrients by adjusting their feed. And they're finding new ways to process them to make all those good minerals even more available for our bodies to use.
Which really just leaves us with one final big question to think about. We have the data on nutrition. We have the data on sustainability. So is it possible that the biggest obstacle standing in the way of a truly sustainable food system isn't a lack of resources on our planet, but simply our own perception of what belongs on our plate?